So we have solved two advanced JEE advanced questions in our yesterday's class. So in today's class, we are going to continue a few more sums and then we are going to start a rolling concept. So the next concept is, so imagine there is a disk or there is a ring, not a disk. So let me take, there is a disk where axis of rotation is passing through the center of mass, having a angular velocity. So actually it is a ring. Okay, everyone, all of you. So it is actually a circular platform whose mass is equals to 50 kg and whose radius is 0.4 meter and angular velocity is equals to 10 radian per second. See that I already given initial angular velocity is not zero, so that initial angular momentum also zero or not zero. Angular momentum, everybody. So before cases and all, angular momentum, initial angular momentum is zero. Now here already having an angular momentum of 10, sorry, angular velocity. So that angular momentum zero or not zero, everybody?
Not zero.
It is not zero. Okay. So now we have to find it. So it is not in rest. So that is, you should remember, it is not in rest, so that we can say angular momentum, initial angular momentum is not zero. Now, two circular rings smoothly, actually, whose mass is like m is equals to 6.25 kg, r is equals to 0.2 meters. Means two circular rings I have been kept. Two circular rings has been kept smoothly at the center of mass. So whose mass is how much? 0.6.625 kg and r is equals to 0.2 meters. So find the final angular velocity of the system. That is what they're asking. So initially that ring is rotating with what angular velocity, everybody? What is the angular velocity initially? 10 meter per second. Now at the center of mass, I have been placed two circular rings whose mass is each one 6.25 kg and radius is 0.2 meters. Now definitely there will be change in angular momentum. Am I right or wrong? Everybody, please respond, guys. Mr. Prados, understanding? So that is what it is. So we have to find it now. So it is also JEE advanced sum, actually 2013 advanced. Okay. So now I have been placed at the center of mass smoothly. Smoothly means they are not having any friction. So two circular rings has been placed. Two circular rings has been placed. So whose mass is how much, guys? Each one. Whose mass is how much? Radius is equals to 0.2 meters. And what is the mass of each one? Everybody, please respond. 6.625 kg. So now they have been kept at the center of mass. So what is the change in angular momentum of the entire system? That is what they are asking. So option A, 1.33, option B, 4, option C, 3.33 radian per second, option D, 8. So this is what it is, options. So now, last two sums you have seen, linear momentum, initial angular momentum is equals to how much, guys? System is in rest. So that angular momentum is in what? Initially, everybody, zero. Okay. Now this ring, it is already having angular momentum. So initial angular momentum is what? Everybody, zero or not equals to zero? It is not equals to?
Not equal to zero.
Okay, which is equals to I omega. So what is the ring actually it is? So ring means axis of rotation. What is the inertia? Rudreswar, fastly. Inertia of a ring alone initially. Pradosh, mr square by 2 into omega. So this is the initial angular momentum. I hope you all understand. Everybody clear? So that is what it is. Next. Now, what else next? Final angular momentum, because both are equal. That is what you have to find. Now you all notice it, all of you. Final angular momentum. Just be very careful. Now you can see, actually the main ring is actually axis of rotation is passing at the center. Now the each ring is present at this point. Now for this smaller rings, axis of rotation is here. Now I want to find the momentum at this point. So I can use some theorem. Anybody can remember what is the theorem I can use?
Parallel axis
Axis
theorem.
theorem. That is very important. Do you understanding all of you? So center of mass, if you have taken a ring center of mass, what is the moment of inertia? Everybody, a ring center of mass, moment of inertia. Yes, please. Everybody. Okay, tell me guys, which is equals to how much? Which is equals to? Yeah.
R square.
That is what. So let me take now, if I take final angular momentum is equals to, so what will happen everybody? L rings, small rings, understanding? Rings plus, so sorry, this is big ring plus two small rings, because two are there. So both at a time I am multiplying with the two. Will you agree? Mr. Rudra sir, brothers, clear up? At a time I am doing it.
Yeah.
So L of the small ring. Okay. So that is what it is. Now, what is a large ring? Can you tell me what is a large ring momentum? Everybody. Just now we have been done. So by the time there is a change in momentum, so I will take it as a, you tell me guys, what will happen? All of you. So what is the initial angular momentum of a main disk, main ring? What is that? M R square by
2.
R square by 2. Okay. Into omega or change in we don't know that is what we have to calculate. Let me take omega dash. Is it okay guys, everyone? Initially alone, yes Rudreswar, yes Pradosh. So initially alone it is rotating with the angular velocity omega. Now after putting the rings, definitely there is a change in angular velocity. Do you all agree with me, everyone? That is only we have to find it. So let's assume that is omega dash. So I'm assuming as omega dash plus 2 into, what is the ring's angular velocity? Anybody can, sorry, angular momentum, you can see that. So if you want to find it, we can say, so I of this rings into angular velocity omega dash. So this I rings, how to find it? By using a parallel axis theorem. So main ring, which is center of mass, and this is the a smaller ring. So here we have to find the inertia. So this how to find it? By using a parallel axis theorem. This is mr square by 2. Now what is the formula we'll use it, guys? Anybody can tell me? Smaller ring. I of smaller ring is equals to I at center of mass of the bigger ring plus m into a square. Will you all agree with me? Everybody? Please respond, guys.
Sir.
Yes, sir.
Yes, Rudreswar, any doubt? Now, that distance between them, which is equals to something, can you tell me what is the radius of the smaller ring? That is what A is equals to smaller. Will you all agree with me, guys? All of you? That is what is
Yes,
the
sir.
radius. I have given it. Yes, Pradosh, are you there? That's all it is now. So now, what is the moment of inertia of the ring at the center of mass? So it is exactly at the smaller ring, actually it is. So at the axis of rotation, what will happen, guys? Now consider only smaller ring. So smaller ring, it is, see that, all of you. At the corner, it is passing. So corner passing, what is the moment of inertia, Rudreswar? Corner, it is passing. What is the moment of inertia? M? Please respond. Corner, guys, it is at the edge, axis of rotation. M? Tell me. Ring ra, check in our notebooks and tell me. This is a smaller ring. Axis of rotation is center. Only smaller ring, not big ring. Forget about the big ring. Smaller ring is attached to the big ring now. So now this smaller ring only we have to consider. So we have to find the moment of inertia of here. And here, if it is axis of rotation, we know that. What is the moment of inertia? Anybody can tell? Please respond, guys. All of you. Center of mass, we know. What is the center of mass, Pradosh? Center of mass, how much it is? Exactly at the center of mass, it is passing.
MR square.
M square by 2.
M?
R square.
R square.
mr square. So mr square. Now it is passing at the corner. So imagine now. How to find it now? So mr square plus m into a value, how much? A is equals to r. So that mr square.
R square.
So I is equals to what, guys? I is equals to 2m.
2
2
MR.
MR.
I is equals to 2mr square. That's all it is. So if you know that, it will be over. Now you can substitute it. So what will happen, everyone? So I can substitute in this formula. So which is equals to mr square by 2 into omega dash plus 2 into what is the I value? Smaller rings. Everybody.
MR square.
mr square.
2
2 mr square into omega dash. Okay, because angular momentum. So we all knows that initial angular momentum is equals to final angular momentum. Just you can equate it. That's all you will get it. What is the initial angular momentum? Check your things here. Initial angular momentum. mr square by
Square by 2 omega.
MR square 2 omega.
mr square by 2 omega. This is for bigger ring. Okay, which is equals to mr square by 2 for disk ring. I forgot it. Rudra,
Sir, MR square by 2 discussion.
yeah,
Sir.
disk. So sorry. So it is a disk, guys. So inside there is small rings has been kept. It is a circular platform of a disk. Okay, wow. Now, Pradosh, are you clear? Yes.
Yes, sir.
Yes, sir.
Yeah, that's what it is. So sorry for that. You can change it. So now you can see that. So mr square. So mr square omega. Then final angular momentum is what? mr square by 2.
MR square by 2 omega dash.
Omega dash is common outside. So omega dash. mr square by 2 plus. What will happen? 2 2s are 4. 4 mr square. Okay, wow. Ellame clear? All of you? Yes, please.
Yes, sir.
Yeah.
Yes, sir.
So what is the capital M? Capital M mass, how much it is? 50 into capital R, 0.4. Let me take whole square. So 0.4 into 0.4. And initial angular velocity. Initial angular velocity how much? 10 divided by 2, which is equals to omega dash. Capital M is how much? 50 into capital R is 0.4 into 0.4 divided by 2 plus 4 into small m, how much, guys? Small m, 6 point,
0.62.
yeah, 6.625.
2.
Yeah, 6.625 into 6.625 or yeah, 6.625 into what is the smaller value, guys? 0.2. So whole square. So 0.2 into 0.2. In this step, anybody having any doubt, you can ask me. Are you clear? Mr. Pradosh, Rudreswa? Yes, Manya and Samya?
Yes, sir.
Anything doubt? Please let me know. So who is Sai Karthik? Understand Sai Karthik? Mr. Rishi? Murali not there, Narayan not there. Okay, yeah. Okay, so that's all it is. Now, what way you can simplify? Pradosh, tell me, what is your best way to simplify this? Your choice. I don't have any problem. So you can try to do it. Then I will follow you people. What is your simplest way to solve this? Yes. Anybody? Yes, Pradosh. You can solve it. So how the what way you can simplify it? You just verify it and you can solve it very simply. Okay. So now you can see. Oh, here I have written square, not required. You can all finish it very simply. It is how it will be. You just see it everywhere. Now, can I get cancel 0.4, 0.4 and 0.4 and 0.4? Everybody? Are you clear?
Yes, sir.
So this side I can see. This side I can write omega dash is equals to 50 by 2 plus. Now you all can see, guys. Everybody. 4 into 0.2 into 0.2. How much, Ra? 0.2 into 0.2. How much, guys?
0.04.
0.04.
Yeah. So 0.04. Now let it be this one. You can see that. 500, 50 into 100, 500. So 500 divided by 2. How much it is?
250.
250. Okay. So omega dash plus. Now this one you all can see that. So 6.625 into 4 into 0.04. So I want to make it and simplify it. Is there any possibility?
0.265, sir.
Huh?
0.265.
This total, Amma?
No, sir. 6.624 into 0.04.
Yes, yes. So 6.625 into 0.04, correct? Which is equals to
265.
0.265 into 4. Into 4,
Sir,
yes, Pradosh?
1.0.
sir, how, sir? 0.40.
No,
cancel.
we have done mistake. Yes, somewhere we are doing mistake. So what way we
Sir,
can?
0.4 we cannot cancel, sir. It is in addition.
Yes, brother. Yes, Rudresh, sir. Correct. So now what is another way? I have to simplify it. So in such a way, 1 minute. Now you can see that this is what I forgot. Yeah, 0.4. Okay. So now 1 minute. It is an addition. Yeah, it is correct only. So let me take now. It is I'll multiply 4 into how much it is, Rudreshwar? 6.625. It will multiply 6.625 into 0.2 into 0.2. How much it is? 0. Yes, please. 0.265. Correct? Yes, Ra? It is 0.265 into 4. Into 4, how much, Ra? Into 4, if I make it, how much it is?
1.06.
1.06 into 2. 2.12 is coming. So what way we can? There is no possibility. Okay. So let me take now. Let us go with the normal way. Is there any possibility of simplifying? Any others? Pradosh, are you there?
Yes, sir.
What way we can simplify? 0.4 into 0.4. This is 0.16. Any other things, Rudraswar? Okay, you think over it because I want to make it simplify so that you people cannot face any easiest way we have to solve it. We cannot spend time on normal calculations. Any other? Think over it, let it be. Yes, I am also thinking so that we will continue.